Okay, so hello and welcome to lecture number 15 of the 2020 Advanced Earthquake and Tsunami Hazard Training course. My name is Hallie Putera. I am a geologist with the Earthquake Science Center based in Menlo Park, California, for the United States Geological Survey. And today we are going to be talking about volcanoes, earthquakes, and volcanic hazards. So by now you have become very familiar with this type of map, this map even in particular since it's been on all of our title slides. You've seen this map in different variations looking at tectonics and seismic data, but today we're going to be looking at the volcanoes on this map. So the volcanic arcs in Indonesia are subduction related. So as the Australian plate descends into the Sunda Java Trench, dehydration melting happens in the mantle and magma rises up and produces a volcanic arc. So the volcanic arc on the western side of Indonesia extends through Sumatra, Java, and into the Banda Arc, even though the tectonics are a little bit more complicated on this side. And then we also have a couple other arcs to the north, fueled by the subduction of the Malacca Sea Plate to the east and the west. Now Indonesia has around 147 volcanoes, with 76 of those being active volcanoes. And previously you have seen this seismic plot in my lecture number 4 on the tectonics of eastern Indonesia, and in that presentation we used this plot to sort of look at the shape of the plates, so looking at the relative depth of these earthquakes, so red being the deepest ones and blue being the shallowest ones, and so there you could imagine which direction a plate is subducting. But now we're mostly going to be looking at the shallow earthquakes. These are greater than magnitude 4, so it's not absolutely littered with earthquakes, but here, looking at the blue dots, you can see that they pretty much follow that volcanic arc as it is parallel to the Sunda Java Trench and up here by Halmahera. And this is a seismic plot is very important just because earthquakes and volcanoes are very much intertwined. So before a volcano erupts, there will often be a lot of tremors in the area, so a lot of earthquakes. A lot of them will be less than magnitude 4.0, but sometimes you can generate a very large earthquake prior to or even after a volcanic eruption, just because as that magma is rising to the surface, it alters the crust, it expands the crust, and things are moving around, and so there's a lot of earthquakes generated with that. So looking at seismic data is very important if we want to try and predict an eruption and evacuate people out of an area before any serious hazards begin to hit a nearby town or agricultural center or anything like that. But now we're sort of going to get to the meat of the presentation. So now we're going to talk about volcanic hazards and sort of volcanoes that have had recent eruptions that show examples of these hazards. So I have no doubt that all of you probably know these volcanic hazards by heart because they are super important in places with a lot of volcanoes, because knowing these can be the difference between life and death. And many places that are located near a volcano definitely have a plan of action if any of these hazards were to impact a town lying at the base of a volcano or nearby. But we're going to go over them anyway, just to sort of nail it down and make sure that that is the case. So our first volcanic hazard is tephra and ash. So you can have explosive volcanoes and non-explosive volcanoes. A non-explosive volcano just sort of ejects steam. Sometimes there's some lava bubbling out of the top. But all explosive volcanic eruptions will generate tephra. And tephra is just fragments of rock that are produced when magma or rock is explosively ejected. So this is where you get your blocks, your bombs, your lapilli, and something, the smallest of sort of these projectiles is classified as ash, and ash is less than 2 millimeters in diameter, and it is very light, and so it is easily convected upward within a volcanic plume, and then is carried downwind for a very long distance. Eventually it will fall out of suspension and sort of work like a rain or snowfall, and this can potentially affect communities and farmland across hundreds of square kilometers. So ash doesn't necessarily endanger a human life by itself. Maybe if you have respiratory issues and are breathing in ash, that might not be great. But ash poses a danger to aviation and infrastructure. So a plane should not be flying through a volcanic ash plume, just because visibility issues, first of all. Second, ash can cause extreme damage to the hull, like the exterior of the plane, and it can possibly jam the engines and cause the engines to fail. So that's a serious problem. So most of the time, if there's an ash plume, an airport will be shut down, and planes will not be able to fly during that time. But then it can also cause problems with infrastructure, so it can cover up roads, it can cover up buildings. Sometimes if the ash is heavy enough, it can collapse a building. But it also has a problem when it covers like grazing lands for animals. If the animals cannot get to the grass, they might starve. And it can cover agricultural fields and cause the death of certain crops. So it causes sort of secondary hazards rather than being a hazard in and of itself. So then our next hazard is lava flows. So lava flows aren't a huge deal, mostly because they travel so slowly. The type of lava that is erupting from the volcano will dictate the flow shape and the travel distance of the lava flow. So for instance, if you have a fluid basalt flow, which is less siliceous and less viscous than like an andesitic flow, it will only flow at about 10 kilometers an hour on steep slopes, so not that fast. If it is confined to a lava tube, which will insulate the lava, flow can reach velocities of around 30 kilometers an hour. However, if you have more viscous flows, like a viscous andesite flow, these only move a few kilometers per hour and rarely extend more than about 8 kilometers from their vents, so they don't move very far. However, everything in the path of an advancing lava flow will be either knocked over, surrounded, buried, or ignited by the extremely hot temperature of the lava. So if you are a person, a lava flow doesn't necessarily endanger you because it moves very slowly. However, it does cause a lot of destruction in its path, so it will easily like bury a house or a field or anything. So you can run away from it. It won't necessarily be a casualty to you, but a flow can cause a lot of secondary hazards that will then be a danger to a person. Like if a lava flow erupts beneath a glacier or flows over snow and ice, the meltwater from this can result in a lahar, which will reach much further than the lava flow. If this flow enters a body of water, or some water somehow finds its way into a lava tube, the water then may boil violently and cause an explosive shower of then molten rock. If a lava flow flows over a lot of vegetation, this could release methane gas, and if this gas somehow is able to migrate into a subsurface void, it can explode if it's exposed to a lot of heat. So that's a serious sort of hazard that comes along with a lava flow, but is classified as a secondary hazard. So then another hazard that can occur is a lahar. So I already sort of brought this up, but a lahar is basically just a mud flow. It's a hot or cold mixture of water and rock fragments that flow down the slope of a volcano and will typically enter into a river valley, so sort of follow the path of water. If this occurs in small seasonal events, it's sometimes referred to as a debris flow. But lahars can occur with or without a volcanic eruption. So an eruption may trigger a lahar by melting snow and ice or by ejecting water from a crater lake. Pyroclastic flows can generate a lahar because this pyroclastic flow will descend down the side of a volcano and basically clear it out because it destroys everything in its path, so all you're left is with this volcanic sediment. And if a severe or heavy rainfall follows that pyroclastic flow, then you can generate a lahar very easily. And then it can also occur without the help of an eruption. So if a volcano doesn't have a lot of vegetation on its side to sort of anchor that soil, the next rainfall that occurs will most likely trigger a lahar. So these are known for causing serious economic and environmental damage to river valleys and floodplains. So since they carry a lot of debris and can move relatively quickly, buildings and valuable land can be partially or completely buried or destroyed. It can also destroy bridges and roads. So because of this, they can trap people in areas vulnerable to other hazardous volcanic activity, especially if the lahars leave deposits that are either too deep, too soft, or too hot to cross. So having a plan to sort of combat a lahar is a big one, just in case a town gets stuck in one and then can't escape any other sort of volcanic activity. So this is why evacuations are very important methods of combating volcanic hazards. So then our next hazard is volcanic gas. So magma itself contains dissolved gases or volatiles, which provide the driving force that causes most volcanic eruptions. So as the magma rises to the surface, the gas is then released and sort of makes its way into the atmosphere. And so here are just a couple of gases that could possibly be dangerous to humans and areas around volcanoes. So first we have carbon dioxide. So carbon dioxide erupts out of volcanoes in a lot of tons. Like there's a lot of carbon dioxide that will come out of a volcano when a volcano erupts, but it's only really dangerous when it gets cold, in a sense. So if your carbon dioxide is cooler than the air around it, it will sink because it's denser than air. And so what usually happens is that you have cold CO2 pockets that sit in valleys or like craters or other low-lying areas. And so this is why they'll usually tell you not to camp in a volcanic valley, just in case there is a pocket of CO2, because we as humans cannot see or smell carbon dioxide. So if you camp in a volcanic valley and fall asleep, you might not wake up. You will most likely suffocate if there is a large amount of CO2 lying in that valley. And then this brings us to sulfur dioxide. So sulfur dioxide irritates your eyes, your skin, and your respiratory system. This is what produces volcanic smog. So this is sort of the fog that you see come out of a volcano. That's sulfur dioxide. And it can also cause acid rain. So if it rises high enough in the atmosphere, it will dissolve into the water there and then produce acid rain, which can be especially erosive. And then next we have hydrogen sulfide. So this is only really toxic in very high concentrations. We can perceive it in very, very low concentrations because it smells like rotten eggs. So it contains sulfur, so the smell is very distinct. This will only really kill a person if it's upwards of 500 ppm, but that doesn't happen very often, but it is still a toxic gas that can be extruded out of a volcano. And then lastly, we have our hydrogen halides. So these are strong and toxic acids. So these acids erupt out and they have a high solubility, so they can rapidly dissolve in water, and so much like SO2, they can also create acid rain. But the hydrogen halides also have the ability to coat ash. So as an ash plume rises, some of it may be coated in these hydrogen halides, and then as that ash sort of falls back down after it loses its suspension, it can poison agriculture. So when that ash falls into a river, it will poison your water. If it falls on plants, it'll poison your plants. So it can cause a lot of harmful problems. So next we have pyroclastic flow. So this is what most people think of as being one of the most dangerous volcanic hazards, just because it's unavoidable if it's coming towards you. Pretty much it moves very, very quickly, and it's very dangerous. Most people think of Mount Vesuvius in Italy, which a pyroclastic flow devastated the town of Pompeii. But a pyroclastic flow is also called a pyroclastic density current. They contain high-density mix of hot lava blocks, pumice, ash, and volcanic gas, so many of the things that we've already talked about, just as a combination. They move at very high speeds down volcanic slopes and also typically flow into valleys. It mostly consists of two parts: a lower basal flow of coarse fragments, so like a whole bunch of rocks that move along the ground, and a turbulent cloud of ash that rises above the basal flow The temperatures of rocks and gas inside these flows are generally between 200 degrees Celsius and 700 degrees Celsius, so they can ignite fires and melt snow and ice very easily. And so if you look at a pyroclastic flow during the day, you'll mostly see this gray cloud that's pictured here. But if you look at it at night, because of those high temperatures, it'll look a little bit red. You'll be able to see those hot basal flows sort of running down the mountain. But pyroclastic flows can lead to a lot of secondary hazards, especially flooding and lahars. So we already sort of went over that. As the flow kind of clears out the area, the next rainfall that happens will most likely induce a lahar. And then since they flow into river valleys, they can also block streams and so cause a lot of damming and then eventually some flooding in the area. So then our last hazard are volcanic landslides. So a landslide is different from a lahar because a lahar is more of a mud flow, whereas this is generally larger and move very fast. So these are common on tall, steep, and weak volcanic cones. If anybody knows the eruption of Mount St. Helens in the Cascades in North America, this one had a large volcanic landslide. So as the magma built up beneath that volcano, it sort of formed a huge dome, and as it exploded, almost half of the mountain sort of descended and slid down and caused a very devastating landslide. So looking at this picture, we can sort of see that same sort of characteristic of how one side is completely slumped, and the downward portion of that sort of has this hummocky texture. That's another sort of mark, if you know a volcano has had a landslide, is looking at the very base, and you see this sort of lumpy, what's called hummocky texture. Volcanic landslide can be very dangerous if a volcano is located near water. So if a volcano is next to water or is itself an island, and the part that slumps off hits that water, it can generate a tsunami. And so tsunamis are usually what end up killing a lot of people, or being one of the most dangerous hazards related to a volcano. Just in case you don't know the sort of symptoms of a tsunami. So if you think about a wave in the ocean, the water will sort of suck back before the wave crashes forward. So if you were on a beach and you notice that the ocean is retreating a very far distance back, it is then your prerogative to sort of get as far away from that shore as fast as possible before that tsunami hits. There will definitely be flooding and a lot of damage, but as long as you are not in the way of that incoming wave, then you have a much higher chance of living than if you didn't. So that's pretty much it for our main volcanic hazards. So now we're going to sort of look at a bunch of volcanoes that have had recent, relatively recent eruptions, and volcanoes that have had particularly cataclysmic eruptions. So first we're going to look at Mount Agung. This one is located on Bali, and it has an elevation of around 3,000 meters. So that's sort of what it looks like. You can see that it's relatively tall. It's surrounded by other volcanoes. So here is Bali, just for reference. It's to the east of Java and a little bit south of Sulawesi. Mount Agung is located on the most eastern side here. You can see some other volcanoes located on that island, but we're focusing on this side. So Mount Agung has had a couple of notable eruptions. So there was a big eruption in 1843, but we're going, since records are sort of not common for that one because it was so long ago, we're going to be looking at the 1963 eruption and the 2017 eruption. So in 1963, Agung exploded with a VEI of 5. So VEI stands for Volcanic Explosivity Index. And this index is used for volcanoes that erupt with an explosion. So you can have non-explosive ones, like we already sort of talked about, so that's a VEI of 0. So those are the ones that are sort of just erupting steam or just lavas bubbling out. You see that in Hawaii on some of the volcanoes. There's a lot of non-explosive volcanoes there. But this one had a VEI of 5. So that puts it at paroxysmal. And so this puts it on sort of par with Mount St. Helens. So if you know anything about the Mount St. Helens eruption, you can sort of keep Agung in mind with that same sort of amount of hazards that was associated with it. So a very big explosion. So it erupted on March 17th. It sent debris 8 to 10 kilometers into the air and generated a lot massive pyroclastic flows, basically. And then these flows were what devastated numerous villages, which killed an estimated 1,100 to 1,500 people. Cold lahars, then caused by rainfall that followed, killed an additional 200 people after that. So looking at this map, we can sort of see the effects of a volcano with a VEI of 5. So you can see how big of an area would be impacted by that. So the warmer colors on this map are from the 1843 eruption, but we want to look at the cooler colors. So our sort of medium blue here that extends really far out, this was our ash fall. So you can see that the plume erupted into the air and then was carried downwind and impacted pretty much most of the island of Bali with that eruption. Our darker blue line here is our lava flow, so again, a very narrow path, not a lot of destruction associated necessarily with a lava flow, but it definitely ate up everything in its path and is now buried under that magma because there's no way to sort of clean that up and get that back. Our lighter blue here, these were our deadly pyroclastic flows. You can see they sort of brushed out in all directions, and then our green color are the lahars that followed that. So then Agung also erupted in 2017. In September of 2017, the area experienced around 844 volcanic earthquakes. So this was why seismicity was so important to a volcanic eruption, because all of these earthquakes happened prior to Agung beginning to erupt. So this sort of alerted scientists and the authorities to get people out of the area, to evacuate around the base of the volcano so that people wouldn't be impacted by the hazards that followed. So this eruption was categorized with ashfall, lava flows, and lahars. But people were evacuated out of the area. And the volcano has sort of continued to erupt for the past couple of years, so it's sort of more of a 2017 to 2019 eruption. But that's just sort of been an on-off situation that's been happening with that particular volcano. So our next volcano is Gelonggong. So this is located in West Java and has an elevation of 2,100 meters. So looking at this picture over here, you can see the plume that rises out of here, how large it actually is. So this is pretty much all ash and gas. And then down here, this is sort of the aftermath of a lahar that happened. You can see all sort of the debris littering and covering this river valley here. So it's pretty much destroyed that valley. But here's where it's located in Java. So it's this little red dot on this map. Over here you can see that it's sort of in a cluster of other volcanoes, some of them being pretty notable, like Papandayan is a volcano that's erupted relatively recently, I think, and then Krakatoa, that's world famous, that lies in the Sunda Strait. So it's in a pretty big cluster of other volcanoes there. But this, the last major eruption on this volcano was in 1982, and it had a VEI of 4, and it indirectly killed around 18 people in traffic accidents and also by starvation. This eruption also brought the dangers of volcanic ash to aviation, to worldwide attention. So during this eruption, 2 Boeing 747 passenger jets were flying downwind of the eruption and fell into the ash cloud and suffered temporary engine failure and damage to their exterior surfaces. And so both planes were forced to make emergency landings at Jakarta Airport. So that's sort of the reason why we know not to fly planes into ash clouds now, but it was a very serious incident, and it's not great for the safety of airlines. It's not worth endangering passengers while a volcanic eruption is happening, so a lot of planes are grounded when that happens. Looking at the shape of the Gelonggong crater, so over here, this is just sort of what happened in the 1982 eruption, but we're looking at the shape of this now. So the shape of this crater is evidence for a massive landslide. So the landslide probably happened within the last 23,000 years, and we know that because of radiocarbon dating. But here is just an example of what a slumped volcano sort of looks like. So you can see that a piece of it definitely slumped off here, and down here we have some hummocky texture. Now, this volcano wasn't next to a body of water, so this landslide most likely did not induce a tsunami, but we are going to look at some volcanoes in a bit that did induce tsunamis with their landslides. So, Khulud. Khulud is another volcano. It's located in East Java. It has an elevation of 1,700 meters. So here's where it's located more specifically, so down there in Java. This one is also located in a large cluster of volcanoes. It's over more towards the central side. And Khulud is a volcano that erupts relatively frequently. So I put some of the more devastating eruptions in recent history, but it has erupted before this, at a consistent basis, basically. So the 1919 eruption had very deadly lahars. There were around 5,000 people killed with that eruption. In 1990, there were several pyroclastic flows. In 2007, this was a non-explosive eruption. It was categorized as a slow eruption just because it went over many months, but without an initial explosion. So there were seismic events attached to this, and so there were evacuation concerns. So the authorities tried to evacuate people, but there were some issues with that. Some people didn't want to leave, and that's usually a common problem with evacuation protocol, is that sometimes seismic activity can happen months before a volcano actually erupts. So getting people to evacuate can sometimes be tricky because they don't necessarily want to leave for that long, or don't want to leave just because the volcano might not erupt at all, and so it's just sort of an inconvenience. But it is sort of a necessary precaution to take. And then 2014, it did explode with a VEI of 4. This eruption prompted about 76,000 people to evacuate their homes. 2 people actually were reported dead after their house collapsed from the weight of the ash that fell. And ash also caused the shutdown of 7 airports, which then caused some issues with distributing goods. So a lot of products were necessary to get out of the area by plane, but because the planes had to be grounded by the amount of ash, this caused a little bit of an economic issue. But ash was a big one with this eruption. So you can see this picture was taken from that 2014 eruption. You can see the ash coating all of these houses and sort of polluting the stream that's in between. But this eruption, other hazards, so we had ash fall, we had some pyroclastic flows, and some lahars. So then moving on to Krakatoa. So Krakatoa is one of the most famous volcanoes in the world, I would say. It's located between Java down here and Sumatra up here, so it's in the Sunda Strait. It sort of was its own island back when it was a whole volcano. So this Krakatoa erupted in 1883, so it had a VEI of 6. So this is labeled as a colossal eruption, so a very, very large explosion occurred when Krakatoa erupted. It was categorized by ashfall, pyroclastic flow, lahars, and most importantly, tsunamis. So the eruption of Krakatoa at a VEI of 6 was equivalent to 200 megatons of TNT, which is about 13,000 times the size of the nuclear yield of the Little Boy bomb that devastated Hiroshima, Japan during World War II. So the explosion that happened when Krakatoa erupted was the size of 13,000 nuclear bombs. So it was a very large explosion. So when this erupted, it's estimated that at least 36,000 people died, mostly from the tsunamis that followed this explosion, and the eruption destroyed 2/3 of the island of Krakatoa. So when 13,000 nuclear bombs went off, 2/3 of an island hit the ocean and sort of generated a large amount of tsunamis that were most likely very high in height, as in meters, and caused a lot of injuries and casualties. But related to that, we can now talk about Anak Krakatoa, which is the child of Krakatoa. So here, it's located in the exact same place. So here is sort of the old island of Krakatoa before the 1883 eruption. Here is what sort of exploded off of the volcano after that eruption, and then this is the new volcano that has sort of risen in its place. So there's been a lot of smaller, like minor eruptions that have helped build up that volcano again, but its size does not mean that it's any less deadly. So Anak Krakatoa erupted in 2018 with a VEI of 4. This occurred on the 22nd of December and then caused a deadly tsunami with waves up to 5 meters in height that made landfall. A couple days later, the casualties, the tsunami death toll was around 437. So this makes this the deadliest volcanic eruption of the 21st century so far due to those tsunamis. So here you can see sort of the explosion that happened. So here was the old summit of that volcano. You can definitely see that a volcanic landslide took place, and you can even see the ring of sediment as it entered the water. And then this landslide was most likely induced those tsunamis that caused all those casualties. But this volcano also had ashfall, pyroclastic flows, lahars, but because nobody was living on that island, it got most of its hazards came from the tsunami that followed it. This volcano also erupted in April of 2020, but there was no widespread damage, just a couple of lava fountains, which is pretty standard for this volcano because it built itself up very, very quickly. So now we're going to be talking about Merapi. So this one is located in central Java with an elevation of around 2,900 meters. So it's pretty much right directly in the center of Java, so it's this last little circle here on this sort of trio of volcanoes located right here. And Merapi also erupts relatively frequently. In 2006, there were early tremors in April, and then lava flow began in May. Again, many people defied evacuation just because there wasn't sort of any symptoms happening with the volcano, so that they could feel the tremors or whatnot, but there wasn't anything happening, so a lot of people didn't want to leave. But then on the 27th of May, a 6.3 magnitude earthquake struck roughly 50 kilometers southwest of Merapi, which killed at least 5,000 people and left at least 200,000 people homeless. So a really awful tragedy. But this just shows that larger earthquakes can occur sort of with a volcanic eruption and can be very deadly. In 2010, this was an explosive eruption, so this had a VEI of 4. It induced ashfall, pyroclastic flow, and lahars. It erupted for about 2 months, from October to December. The death toll was about 350. And then in 2018, it erupted again, but this was a phreatic eruption, and that just caused an immediate evacuation of the area, and that's a much note there is with that one. So then the last two we're going to be talking about were not necessarily recent, but they were particularly cataclysmic. So here is Tambora. Mount Tambora is located on Sumbawa Island, and it's a very large volcano. Here in this picture, we're sort of looking down into the crater, and you can sort of see the size of it on this map over here. But this volcano erupted in 1815 and had a VEI of 7, so that makes it a super colossal eruption or explosion. So this was categorized by ash flow, pyroclastic flows, and tsunamis. Again, tsunamis being very deadly. So the explosion, it's said, so if we remember, Krakatoa was about the size of 13,000 nuclear bombs. This one was even bigger than that, a whole number bigger than that. And the explosion was heard all the way on Sumatra Island, more than 2,000 kilometers away. There were heavy volcanic ash rains that were observed as far away as Borneo. And the maximum elevation of Tambora was reduced from about 4,300 meters to about 2,800 meters. And so, although estimates vary because it was such a long time ago, the death toll was at least 71,000 people. This eruption was so large that it caused a global climate anomaly in the following years. So 1816 became known as the year without a summer due to impact on North American and European weather. So in the northern hemisphere, crops then failed and livestock died, which result in the worst famine of the century. So that just shows how one little volcano in Indonesia can sort of have a global impact if the explosion is big enough. So the last volcano we're going to talk about is Toba. Nowadays it's known as Lake Toba, but this is a supervolcano. So this is located on the island of Sumatra here. It's this oblong lake up to the northern side. And Toba last erupted around 74,000 years ago, but this was a VEI of 8. It is one of the largest, if not the largest, explosion recorded in history that we know of. And it was categorized by ashfall, pyroclastic flow, lava flow, and of course tsunamis. I mean, it's to be expected due to the absolute monstrosity of this. This was a mega-colossal, I think, is the term for it, explosion. And just to sort of give you an idea of the size, here is our Krakatoa bubble, and you remember our Krakatoa is 13,000 nuclear bombs. And then you look at that bubble compared to the size of our Toba bubble here, and you see that it is very much devastating. It's generally accepted that the eruption of Toba led to a volcanic winter, so probably a lot of the same issues that occurred with the eruption of Tambora. Just for comparison, in North America we have another supervolcano, Yellowstone, and that one is even still smaller than the eruption of Toba. So a very huge explosion occurred, pretty much unimaginable in its size. So then pretty much in summary, we talked about volcanic hazards. To keep in mind, ashfall, lava flows, lahars, volcanic gases, pyroclastic flows, and volcanic landslides. It's important to have a plan to sort of combat each of these hazards. And then we also looked at volcanoes with recent eruptions and then the dangers they pose. And that's going to be about it for this lecture. I hope that you learned at least a little bit or found the volcanic information interesting. But yeah, thank you so much for listening, and I will see you some other time.